The universe is an infinite fractal composed essentially of an infinite number of cosmic explosions known as little Big Bangs. If you consult a science textbook published before 2006, you will see that Pluto was included as one of the 9 planets in our solar system. However, this is no longer the case. Almost 17 years ago, the International Astronomical Union, IAU, redefined Pluto's status and excluded it as a planet. Now, the IAU is again debating this issue because NASA has provided clear images of Pluto, now considered a dwarf planet. Join us on a journey to the far reaches of our solar system to explore the first images of Pluto in our history. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. We've come a long way since the historic Apollo 11 mission, but the vastness of space poses many unanswered questions. This is where NASA's groundbreaking James Webb Space Telescope project seeks to discover a world of its own. This monumental project builds on NASA's previous missions, and there is great interest in translating special discoveries from prehistory. We are understandably curious to learn more about the Big Bang and how our solar system came to harbor life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our solar system, revolutionizing our understanding. Although it is important to ask whether we need to look back for definitive answers about our universe and perhaps reevaluate them, the Pluto question has been the subject of controversy in the field of space exploration. Thanks to the James Webb Telescope and the discoveries it has provided, we have more and more information to explore our solar system. It seems that the $11 billion investment in NASA has led to a revision of science textbooks to include everything we know about Pluto. This time, it is likely to regain planet status. Here's why. Our knowledge about Pluto doesn't end with the controversial IAU decision in 2006. In fact, it is the new and renewed capabilities of the James Webb that have provided the pictorial evidence needed to strengthen our theoretical understanding of this putative planet. Although previous observations categorized which objects are considered planets and which are not, the IAU had little solid data on which to rely. The rules used for this categorization may have been questionable after the decision in 2006. 2 different scientific positions on the issue emerged. Some believe that the IAU was hasty in declaring Pluto a dwarf planet, while others quickly embraced the new non-planet status. Most space explorers have remained undecided on the matter. However, thanks to the fascinating discoveries of the James Webb, the question of Pluto's status remains open. The first sharp images of Pluto provided by NASA are rewriting our understanding of cosmic history. The first and primary human encounter with Pluto was conducted by the New Horizons mission, which has been underway for 17 years. In July 2015, the mission achieved its goal by passing close to Pluto and its many moons. This was the first time humans were able to get a close look at the space relic and collected the most comprehensive data set to date about its moons and surface. The New Horizons mission opened up unprecedented possibilities for NASA in its exploration of the Kuiper Belt, a deep region of space. The main achievement of the mission was the detailed study of Pluto, now considered a dwarf planet, and its largest satellite, Charon. It also managed to capture clear images of the 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission collected data, including the encounter with Pluto and Charon, totaling 6.25 gigabytes. What does this data mean for NASA in relation to the dwarf planet? First, the findings were so groundbreaking that scientists had to develop new data models to better understand Pluto's surface and atmospheric conditions. It was discovered that the dwarf planet was undergoing significant changes in its surface and atmosphere. It was clear that Pluto was far from being a dormant body. It was evolving at a rate that surprised NASA and challenged what was previously believed about this putative planet. The New Horizons mission was groundbreaking, and its encounter with Pluto took place nearly 80 years ago. Since then, the field of space exploration has seen dramatic improvements through technological intervention. With the addition of the James Webb Space Telescope, the possibilities are becoming endless. One might even say that we are getting closer and closer to a complete understanding of our solar system. However, there is an issue with missions like New Horizons and any options to explore planets farther from the Sun. The problem lies in the prioritization of resources, as investing millions to investigate a scientifically important planet may raise questions about the existence of possible life forms elsewhere. Why head to the edges of the solar system? These are challenging questions to be sure. However, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the exploration of Pluto, but it also piqued our interest in further exploration beyond the known confines. In the case of Pluto, its study is fundamental to building a broader scientific understanding of other small planets. Although it lies in a cold, dark region of the universe, the first images of its surface proved groundbreaking enough to reveal that Pluto is an active object in our solar system. As they say, a picture is worth 1,000 words, and these crystal-clear images from NASA provide us with valuable information. First, Pluto was found to have a heart. Most geological phenomena on this dwarf planet are driven from its core, scientifically known as Sputnik planum. Surprisingly, it turns out that Pluto literally follows its heart. A quick glance at NASA's high-resolution images revealed that this heart is a white, cold, and nearly frozen left ventricle of Sputnik planum's heart. It resembles a vast nitrogen glacier spanning millions of square kilometers. Another notable geological feature of Pluto's surface is that the axis of its rotation has undergone significant reorientation, a process scientists call precession. This was unknown to NASA prior to the mission. The dwarf planet's basin is in the opposite position than expected. This reorientation has important implications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the tidal axis between the moon Charon and Pluto is being influenced by Sputnik planum, the heart of the dwarf planet. This influence has reoriented Pluto so that its basin is more closely aligned with the tidal axis, something that was not previously known. We have always known that this ancient planet is uninhabitable for obvious reasons. However, what was not known is that Pluto's icy surface also causes a tilt due to the imbalance in its mass. The core of the heart of the dwarf planet is a 4 kilometers thick layer of ice, which is very likely contributing to that colossal mass. When combined with tides, this process can cause the reorientation of the planet's rotation axis in search of equilibrium on its own orbit. However, the ice sheet alone is not sufficient to generate a steep reorientation angle or to produce significant heights. As we mentioned before, technologically backed explorations can rewrite our cosmic history, and this is just such a moment. Scientists have also discovered that Pluto is a world with an ocean of its own. Beneath its thick ice sheets and glacier-covered surface, Pluto's interior contains an extensive ocean that also influences the reorientation of its rotation axis. This discovery is extraordinary for several reasons, but above all because it completely changes our understanding of the planet. The highly probable presence of an ocean in Pluto's crust means that we shall have more information about its origin and how it formed. The discovery of an ocean beneath Pluto's icy surface has ignited new questions and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth and prompts us to rethink the dynamics of celestial bodies in the distant reaches of our solar system. This ocean, hypothesized to exist based on gravitational data and now strongly supported by the New Horizons mission's findings, represents a potential reservoir of liquid water beneath a frozen exterior. Understanding Pluto's geological processes is crucial to comprehending its evolution over billions of years. The dwarf planet's surface features, including its prominent heart-shaped region and the unexpected reorientation of its rotation axis, provide tantalizing clues. Sputnik planum, the heart's left ventricle, acts as a unique geologic feature. It's believed to be a large basin that may have formed due to a subsurface ocean freezing and causing the surface to collapse, or perhaps due to an impact that excavated material, leaving a deep depression. The New Horizons spacecraft's encounter with Pluto in 2015 revealed a dynamic world far from the cold, inert body it was once assumed to be. The mission captured detailed images of Pluto's diverse terrain, including mountains made of water ice, vast plains of nitrogen ice, and regions with complex patterns resembling cellular networks. These features suggest active geological processes, possibly driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, although thin compared to Earth's, plays a crucial role in its surface dynamics. It consists mainly of nitrogen, with traces of methane and carbon monoxide. During Pluto's elliptical orbit around the Sun, these volatile gases sublimate from its surface, creating temporary atmospheres that vary with seasonal changes. Understanding these atmospheric processes helps scientists reconstruct Pluto's climatic history and its ongoing evolution. The New Horizons mission's discovery extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, displayed an unexpectedly diverse landscape, including a massive chasm deeper than the Grand Canyon and a dark region nicknamed Mordor for its distinctive coloration. Other moons, such as Hydra and Nix, showed irregular shapes and cratered surfaces, indicating a history of impacts and geological activity. NASA's exploration of Pluto and its moons exemplifies humanity's ongoing quest to explore and understand the vastness of our solar system. Each new discovery raises further questions about the origins, evolution, and potential for life beyond Earth. As we continue to unravel the mysteries of distant worlds like Pluto, we gain valuable insights into the processes that have shaped our solar system over billions of years. Looking ahead, future missions to the outer reaches of the solar system, equipped with even more advanced technologies, will likely reveal new secrets hidden within the frozen depths of these distant worlds. Whether Pluto regains its status as a planet or remains classified as a dwarf planet, its significance in our understanding of planetary science is undeniable. The ongoing debate over Pluto's status highlights the ever-evolving nature of scientific inquiry and the importance of continued exploration in expanding our knowledge of the cosmos. So, as we gaze up at the night sky and wonder about the countless worlds beyond our own, let us remember that each new discovery brings us one step closer to understanding the intricate and beautiful tapestry of our universe. Whether we look back to the origins of our solar system or forward to its future, the journey of exploration and discovery will continue to inspire and challenge us for generations to come. Exploring Pluto and its moons has broadened our understanding of the outer solar system's dynamics. The revelations from the New Horizons mission have not only updated our knowledge about these distant celestial bodies, but also posed new questions about their formation and evolution. As scientists analyze the detailed data from Pluto's surface and atmosphere, they are developing new theories about the mechanisms that drive its geological activity. One of the most intriguing aspects of Pluto's study is its thin atmosphere, which behaves in complex ways due to its interaction with solar radiation and seasonal changes. This atmosphere undergoes significant transformations as Pluto moves along its elliptical orbit. The sublimation and deposition of gases, such as nitrogen, methane, and carbon monoxide, create a dynamic atmosphere that expands and contracts. This process contributes to the planet's weather patterns and has implications for understanding similar processes on other icy bodies in the Kuiper Belt and beyond. The discovery of varied geological features on Pluto, including ice volcanoes and expansive plains, suggests that the planet's internal heat plays a crucial role in shaping its surface. These findings challenge previous assumptions that Pluto was a geologically dead world. The presence of features like the nitrogen glaciers and the heart-shaped region indicate ongoing processes that are not solely reliant on external forces but also on internal heat sources. This dynamic nature is a stark contrast to the long-held view of Pluto as a cold, inactive world. Furthermore, the interaction between Pluto's moons and its atmosphere adds another layer of complexity. The gravitational interactions between Pluto and its moons, particularly Charon, create tidal forces that influence both the planet and its satellites. These interactions can lead to tidal heating, which may contribute to the geological activity observed on Pluto. The detailed observations of Charon's surface, with its diverse terrain and chasms, provide insights into the evolutionary history of Pluto's moons and their role in the system's dynamics. Pluto's relatively young surface, as evidenced by the lack of craters in certain regions, suggests that the planet has undergone significant resurfacing events. The presence of mountains and plains made of water ice, combined with the evidence of erosion and sedimentation processes, indicates that Pluto's surface has been reshaped relatively recently. This active geological history highlights the complexity of planetary bodies in the outer solar system and underscores the importance of continued exploration to fully understand these processes. As we look toward future missions, the potential for discovering new phenomena and expanding our knowledge of the solar system remains vast. The technological advancements of the James Webb Space Telescope and other future missions will enable scientists to probe even deeper into the mysteries of distant worlds. These missions will likely reveal more about the composition, structure, and history of celestial bodies located far beyond the reach of current exploration. Moreover, studying objects like Pluto helps scientists draw comparisons with other icy worlds in the solar system and beyond. By understanding the similarities and differences between Pluto and other Kuiper Belt objects or distant exoplanets, researchers can refine their models of planetary formation and evolution. These comparative studies are essential for developing a comprehensive picture of the processes that shape planetary systems throughout the universe. In summary, the exploration of Pluto has revolutionized our understanding of the outer solar system. The data collected from missions like New Horizons, coupled with advances in observational technology, continues to challenge and expand our knowledge of these distant worlds. As we advance our capabilities and explore further, the quest to uncover the secrets of our solar system and beyond will drive future discoveries and inspire new generations of scientists and explorers.